welcome to numbers 4. My name is Ravi Prakash and this is the first class of HCF LCM, right? Now, HCF LCM, a very important concept in any aptitude examination, right? There can be several questions about which you have studied in your childhood, or suppose any examinations you're preparing for, right? But in here we'll discuss loads and loads of good concepts with loads of problems, right? So after this HCF LCM is over, again I no need to say that everything is covered. Everything means 200% things will be covered, right? You don't need to refer a single other book or other notes after doing this, right? I'll cover every concept in HCF LCM. Please follow all these videos, right? Okay, let's start with now. We'll start with HCF, right? We'll start with HCF. Now, what is HCF actually? I know, right? All the definitions we know, right? What is HCF? HCF is highest common factor, obviously. HCF is highest common factor, right? Always try to, this is about most basic concepts. Okay, most basic concepts this is about. So always try to get back to the basics, right? Now, highest common factor, that means in between some numbers, what is the highest common factor? Okay, so the most basic thing I'll discuss first. What is the HCF of 6 and 9? Very easy. What is the HCF of 6 and 9? So HCF of 6 and 9, the common factor present in 6 and 9 both. Obviously, it can be directly looked upon, right? No need to take any rules, right? Simply I can say 3. HCF of 6 and 9 is 3, right? Or I can say anything. HCF of 10 and 15 is 5, right? So basically, see, this HCF goes on this difference concept. Very important concept in HCF, right? Very important concept, difference concept. Now, what is difference concept, right? So you see, HCF of A comma B is given as any factor of B minus A. That we need to check, right? But HCF of A comma B is given as will be any factor of B minus A, right? This is difference. The difference concept, right? We take the difference where it should be like B is greater than A. B is greater than A. It should be correct. Fine. Obviously, whichever is correct, we'll take that. Whichever is greater, we'll take that. So HCF of AB is any factor of B minus A. For example, if I say what is HCF of 10 and 18, right? So HCF of 10 and 18, you can by looking you can say it is 2, right? But to start a concept, you can say okay, that is any factor. It has to be any factor of B minus A. That is 18 minus 10. That is equal to 8 equal to 8. So any factor of 8 would be the HCF of 10 and 18, right? So we'll be looking upon, if we write down all the factors of 8 like 1, 2, 4 and 8. So obviously since it is highest common factor, we'll start from looking at 8, right? So 8 does not divide 10 and 18, right? Highest factor means what? Factor means it should completely divide that number. So 8 will not divide 10 and 18. So 8 is not the HCF. 4 will not divide 10 and 18. 4 is not the HCF. 2 will divide 10 and 18. So 2 is the HCF, right? So 2 is the HCF, right? Hold on. I know you can directly do it. HCF of 10 and 18 is 2. Directly do it, right? No need of this. But it is a very good concept. Understand. We'll get it to difficult level. Okay. So HCF of 10 and 18 is what? 2. So we start checking from the highest common factor available. What are the factors available? Any factor of B minus A. Okay. So we started from checking factor of 8. So since we need highest common factor, so we start from the highest number. So 8 does not divide, 4 does not divide both of this, 2 divides. So 2 is the HCF. Therefore, HCF of 10 and 18 is what? 2. Okay, so in the difference concept, see, what I can do is now, what is the HCF of, like, suppose, what is HCF of 108, 126, okay, then 180, and then let's suppose 306. So I need HCF of these numbers, right? So I don't need to calculate anything. If I understand this difference concept, I don't need to calculate much here, right? Don't need to calculate much. So this difference concept goes like this. You pick any pair in these four numbers, you pick any pair which has shortest difference, right? Or smallest difference. That is obviously 108 and 126, right? What is the difference here? 18. So any factor of 18 has to be the HCF. Any factor of 18 has to be the HCF, right? Like what is the factors of 18? 18, 9, 6, 3, 2 and 1. So HCF is for sure among these six numbers only, right? So going by the definition of HCF, HCF of A comma B is what? Any factor of B minus A. So in these four pairs, right, I'll explain you why I'm taking the shortest difference. I'll come to this point. Right now, how to find HCF? So take any shortest difference pair, and what is the difference here? 18. So answer is any factor of 18, right? So since it is highest common factor, we start checking from highest number. So 18, right? See, will 18 divide 108? Yes, it is 6 times. Will 18 divide 126? Yes, it is 7 times. Will 18 divide 120? Yes, 10 times. Will 18 divide 306? Yes, 17 times. So 18 divides all the number. Therefore, HCF is 18. So easy, right? So easy. Hold on. Let me take another example. 93, 292, 496, 107 and 231. What is the HCF of all these numbers, right? 93, 292, 496, 107. So going by this method, what I need to do is take the select the pair with the smallest difference. That is obviously 93 and 107. What is the difference here? Difference here is 14. So for sure, HCF is any factor of 14. That is either 14 or 7 or 2 or 1. Right? Now, since there are odd numbers also here, right? 93 and 107, 231, right? These are odd numbers. So any even number won't divide any odd number, right? So obviously 14 and 2 can't be the HCF. 14 and 2 can't be the HCF, right? Now come to 7. Now 7 should divide all the numbers, but you can see 7 doesn't divide 93 only, right? So don't need to check for other numbers. So 7 doesn't divide 93, so it's not in HCF, right? So what is the HCF? HCF is 1. So HCF is what? HCF is 1, right? So such an easy thing now. What is HCF? How to calculate HCF? Going by the difference concept. If there are two numbers, answer will be difference factor of any factor of their difference, right? If there are more numbers, I will pick the number with a smallest difference, right? Why is smallest difference? I'll explain this point. Why is smallest difference, right? Why is smallest difference? See, last question we took 108. Last slide, 108, 126, 180, and some I think 306 was there, right? I need to find the HCF. Now, why did I take smallest difference? I could have taken this pair difference as 18. Okay, then this pair difference as 54. Then this pair difference as 126. Then again this pair difference as, okay, I can say also take this pair difference. So this pair difference I can also take it as, suppose what is the difference here? 198. So, but if I combine, I need the highest common factor, right? What I need the highest common factor. Okay. So I need the common part in it, right? So since these all are multiples of 18, 18, 3 are 54, 18 into 7 is 126, and 18 into 11 is 198, right? So these all are multiple of 18. These all are multiple of 18 only, right? So what is the HCF? The common part. What is the common part? So common part is the 18, right? So common part is the 18. That means I should always check for this only smallest part, because no matter how big the difference is, right? Always the answer will be what? Answer will be the common factor. What is the common factor? That will be obviously contained in the shortest difference only, right? So why too big for the longer difference or bigger differences, right? So that's why I'm selecting a smallest pair difference, right? Very important concept in HCF. No, doesn't matter 7, 8, 10 numbers are there. Pick a number, pick a pair with the smallest difference. Write down all its factors, and any of the one of the factor will be the answer, right? So check all the factor dividing the number or not, right? And that will be the answer. Very important concept. This one. Okay. Okay. Now, second important concept in HCF. second important concept in HCF, right? Second concept is going by the co-primes. Go by the co-primes, right? So how to go about co-primes in HCF, right? See, when I write HCF of, let's say HCF of 50 and 60, right? So by difference method now, I know that HCF is 10. 60 minus 50 is 10 and 10 is dividing both these numbers, so 10 is the HCF, right? But by co-prime method, another important application, right? By co-prime method. So by co-prime method, what is HCF of 50 and 60? So see, if I take the highest common factor out, right? I know 10 is the HCF, right? So if I know 10 is the HCF, so 50 can be written as 10 into 5. 50, 60 can be written as 10 into 6. If I write like this, 50 as 10 into 5 and 60 as 10 into 6, so I know that, okay, 10 is the HCF now. I know that 10 is the HCF, right? Why? Only like this. I can also write 50 as 5 into 12 and I can also write 60 as, I can write 50 as 5 into 10 and 60 as 5 into 12, right? And 60 as 5 into 12. So in this case, why not 5 is the HCF? Why not 5 is the HCF? Right. So I know that 5 is not the HCF. Why it is not the HCF? Because these numbers 10 and 12 are not co-prime. Are not co-prime. Co-prime means what? Co-prime means their HCF is 1. Two numbers having HCF as 1 are said to be co-prime, or in other language, they should have nothing in common, right? For example, 5 and 6 are co-prime. They have nothing in common, or their HCF is 1. 10 and 13 are co-prime. Nothing in common, or their HCF is 1. 4 and 9 are co-prime. Their HCF is 1, or nothing is common, right? These are co-prime numbers, okay? We have discussed this many times earlier also, right? So 10 and 12 are not co-prime, right? Why not? Why they are not co-prime? Because it is HCF, right? What is HCF? Highest common factor. So from 50 and 60, I have still not extracted the highest common factor out, right? I've extracted 5 out. So if I've taken 5 out, so 5 into 10 and 5 into 12. But 5 is not the highest thing that we can extract. Still these two have got 2 in common. Still 10 and 12 have got 2 in common, right? So I can further extract 2 out. So if I extract 2 out here, so it will be like 10 and it will be like 10. So 10 into 5 and 10 into 6. Now I can say that 10 is the HCF because 5 and 6 are co-prime to each other. Okay, so I can say that 10 is the HCF because 5 and 6 are now co-prime to each other. Very important thing, right? So when I can write a number as some common factor into A and into B, those A and B should be co-prime. Then only I can say that common factor is the HCF, right? For example, one more example I'll take. Let's take an example of 108 and 126. Right. Now 108 is what? I can write it as 18 into 6. 126 is what? 18 into 7. Like it's some common factor. I'm writing in terms of common factor, right? I can also write 108 as 9 into 12. I can also write 126 as 9 into 14. So I'm trying to write in terms of some common factor. So when I can say this common factor, right, obviously, when I can say this common factor is the HCF, when I can say that common factor is the highest, that is the highest common factor, right, when these numbers left out are co-prime, when these numbers left out are co-prime, right, in this case 12 and 14 are not co-prime. 12 and 14 are not co-prime, that means 9 is not the HCF, 9 is not the HCF. Right, what is the HCF? 18. So HCF of 108 and 126 is what? 18. So 18 is the answer, right? This is based on this co-prime concept, right? So very important. Okay. Okay, let's do a problem here. First question I can write. HCF of two numbers is 18 and their sum is 324. Okay, how many such pairs of numbers are possible? How many such pairs of numbers are possible? Okay, so solution. Now how to solve it now? See, so if HCF of two numbers is 18, so you know that N1 and N2 are, let's say, those two numbers, N1 and N2. So I know that 18 is the HCF, that means 18 is common in both the parts. This is the highest common factor. So after extracting the highest common factor out, what is left? The part left is something, let's say, into A and into B, right? Where A and B should be co-prime to each other. A and B should be co-prime to each other, right? They should have nothing in common, right? That their HCF should be 1. So I can directly write like, okay, if HCF of two numbers is 18, that simply means that numbers are 18 into A and 18 into B, where A and B are co-prime, right? Always, right? So if HCF of two numbers is 18, the numbers are 18A and 18B. Okay, so now sum of these two numbers. Okay, so 18A plus 18B is equal to 324, right? So therefore A plus B is equal to what? 324 by 18, that is equal to 18. Okay, so now how many such pairs of numbers are possible? So now we have to see that A and B should be co-prime. A and B has to be co-prime, right? So I can write all those cases where a sum of this A plus B is 18, right? For example, 1 and 17, right? So I can take 1 and 17 because 1 and 17 are co-prime. I can't take 2 and 16 because 2 and 16 are not co-prime. Okay, they have 2 in common. So next, what I should take? I can't take 3 and 15 also because 3 and 15 have 3 in common. They are not co-prime. What is the next one? It should be 5 and 13. Okay, what is the next one? It should be 7 and 11. That's it. That's it. Only 3 pairs are possible. Only 3 pairs are possible. Okay, so again a super concept this is, right? So HCF of two numbers is 18 and their sum is 324. How many such pairs of numbers are possible? So pairs of numbers are possible. 18A and 18B are the numbers. Sum of those numbers is 324. So A plus B equal to 18. Now I have to write down 18 as a sum of two numbers where these two has to be co-prime. These two has to be co-prime, right? This is what? This is nothing but 117, 513 and 711, right? 3 pairs are possible. See, now one question may be clicking your mind is that, is it ordered or unordered? The most famous question, right? What to write? The answer is 3 or 6. Again, same thing. I will repeatedly discuss this thing. In this question, variables are not given. Variables are not given. That means it is unordered solution. Unordered solution. As simple as this, right? Unordered means I don't have to worry about A and B and B and A. They will be only counted as one pair. When the answer will be 6, if the question was question HCF of A comma B is equal to 18 and sum of, and I can write, and A plus B, right? HCF of A comma B is 18, or already A B I have used here, so let's change this term now. Let's say HCF of X comma Y is 18 and X plus Y is equal to 324. Now how many values of X, Y are possible? In this case, the simple answer would be 6 solutions. 6 solutions, right? Because variables are given, this is the case of ordered. If it is the case of ordered now, that means in ordered, A is 1 and B is 17 and B is A is 17 and B is 1. Each pair will be counted as 2 solutions, right? So there are 3 pairs, so each pair will be counted as 2 solutions. So 3 into 2, 6 solutions. So 6 is the answer. Correct. So So got this concept, right? Always variables are given, ordered, variables are not given, unordered. As simple as this, right? Okay, now one more very important concept I'll discuss in next video. Sorry, next question, not next video. Okay. See, second question. Very important question. Hope you remember Euler numbers, right? Second question. HCF of two numbers is 7 and their sum is 1470. How many such pairs of numbers are possible? How many such pairs of numbers are possible, right? I'll tell you what is the need, why it is the need of Euler number here. Pairs of numbers are possible, right? In factors, in remainders, everywhere I have discussed this Euler number, right? I hope by now that you are confident with Euler number. If you don't, if you're not remembering right now, please watch Factors 12 video where I've explained Euler number. I think Factors 12 only, right? Please watch Factors 12 video where I've explained Euler number, and the next video I've explained about the. So you should watch Factors 12 and 13 for Euler number and its application, right? Okay. So how many such pairs of numbers are possible, right? So again, fundamental is same, right? HCF of two numbers is 7, so number can be written as 7a and 7b, where a and b has to be co-prime, right? Now 7a plus 7b, their sum is equal to 1470, right? Now a plus b is equal to what? It is 210. Now a and b I know has to be co-prime, right? So now it's quite difficult to think because we can't count like in last case. 210 is a big number. 1 and 209 is one pair. Then I think 11 and 189 is another pair. Like this, so many pairs will get, right? Not possible to count it manually. So 11 199 I should write. So not possible to count manually. So we had discussed this concept in Euler number, that in how many ways I can express a number as the sum of two co-primes. In how many ways I can express number as the sum of two co-primes. So number of ways is equal to what? Half of Euler number. Half of Euler number of that number, right? That is number of ways in which I can express 210 as sum of two co-primes is equal to half of Euler number of 210, right? What is Euler number of 210? So Euler number of 210. 210 has got 4 prime factors. 2, 3, 5, 7. Okay. So 210 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5 into 1 minus 1 by 7. We'll solve it. We'll get answer as what? 210 into half into 2 by 3. So 210 into half into 2 by 3 into 4 by 5 into 6 by 7. We'll get 48 as answer. So how many pairs will get here? How many pairs will get here? We'll get 24 pairs. That is half of Euler number, right? 24 pairs are possible, and this is our answer. Very good concept I discussed in the factors about Euler's application. Please watch Factors 12 and 13 video, right, where we discussed this concept. Very important. What is the concept here, right? In how many ways 210 can be expressed as a sum of two co-primes? As a sum of two co-primes, right? So funda was same, right? If I list down all the numbers before 210 that are co-prime with 210, so numbers will be like this: 1, they are co-prime with 210, right? So like 1, then obviously 11, then 13, then numbers like 17, like this, right? And last numbers will be obviously like 197, 199, 209, like this. So these are the 48 numbers, right? So always first plus last. 1 plus 209 is 210. 11 plus 189, 199 is 210. 13 plus 197 is 210, right? Right. So like this, there are 48 such numbers. So how many pairs I can form? I can form such 24 pairs, right? To 24 pairs. So simply number of ways in which I can write a number as sum of two coprimes is what? Half of the Euler number. This is Euler number 48. So what is the answer? 24. Yes. Right. Very good question it is. Okay. Okay. Same. Move to third question now. Move to third question.